Okay, final video on partial fractions. So what happens if you have the antiderivative of 10x minus 2x squared divided by x minus 1 squared times x plus 3? So the difference here is that this factor is repeated. And for double factors, as it turns out, we have to do this. We have to set 10x minus 2x squared divided by x minus 1 squared times x plus 3 equal to a over x minus 1 plus b over x minus 1 squared plus c over x plus 3. So in this case, when you have a double factor, you have to do a over a single and b over a double. And if you had a triple, you'd have to do c over the triple. So this is kind of like, it would take too much time to explain algebraically. So I'm just going to ask that you accept it as truth, and we'll see that it works out. But this is kind of something that you need to watch out for if you have a double factor. Otherwise, we approach this problem in the same way. So now we need to multiply everything by the least common denominator, which is always this. Okay? But what we're going to end up with now is 10x minus 2x squared is equal to, a is missing an x minus 1 and an x plus 3. So it's actually a times x minus 1 times x plus 3. B is just missing the x plus 3. So it's going to be plus b times x plus 3. And c is missing both of these. So it's going to be plus c times x minus 1 squared. And this is bad because we have a quadratic term, a linear term, and a constant term. And so we're going to have to set all of that stuff equal and have 3 equations and 3 unknowns. So it's actually a lot of work. Well, let's do it. So we've got 10x minus 2x squared equals. Now this becomes a times x squared plus 2x minus 3 plus bx plus 3x plus c times x squared minus 2x plus 1. So now we have 10x minus 2x squared is equal to ax squared plus 2ax minus 3a plus bx plus 3x plus cx squared minus 2cx plus c. So I need now 0 to equal my constants. That's negative 3a plus c. I need 10 to equal my x terms. That's 2a plus b plus, oh shoot, this should be 3b. This should be 3b. So this should be plus 3b. Whoopsies. So 2a plus b minus 2c. And I need negative 2 to equal a plus c. So I could use substitution or elimination or a matrix. I think I'm going to do substitution and say that in this case c is negative 2 minus a. So I'm going to plug that into both of these and get 0 is equal to negative 3a minus 2 minus a plus 3b, and 10 is equal to 2a plus b minus 2c, which is plus 4 plus 2a. So that gives me 0 is equal to negative 4a plus 3b minus 2, and 10 is equal to 4a plus b plus 4. Now if I add these, which I can do, I'm going to get 10 equals 0 plus 4b plus 2. This is a little sloppy, but it makes sense, and I'm going with it. 8 equals 4b. 2 equals b. So 2 is equal to b. And if I plug that back in here, I get 0 is equal to negative 4a plus 6 minus 2. So negative 4 equals negative 4a, so 1 equals a, and that means c equals negative 2 minus 1, so c is negative 3. So I got 1, 2, and negative 3. And I'm just checking my notes to make sure that is the correct answer. Okay, so that's basically a lot of algebra. It's just solving a system of 3 equations. So just to remember, we had to add an extra b over x minus 1 squared, and that's going to give us this. All right, now let's see if we can apply that to what we want, which is this right here. All right, so we now want to write this in this form. So this becomes the antiderivative of a, which was 1 over x minus 1 dx, plus antiderivative of b, which was 2 over x minus 1 squared dx, plus the antiderivative of c, which was negative 3 over x plus 3 dx. And now we have something that's a lot simpler. Now this is a natural log, this is a natural log. This is just x minus 1 to the negative 2, which we know how to antidifferentiate. So this should be natural log absolute x minus 1, plus this right here is 2 times x minus 1 to the negative 2. So that's just going to become 2 times x minus 1 to the negative 1 divided by negative 1, plus negative 3 ln absolute x plus 3 plus c. So we should get ln absolute x minus 1 minus 2 over x minus 1 minus 3 ln absolute x plus 3 plus c. Wow, what a problem. What a problem. So again, the whole goal is to write it into simpler things so that we can antidifferentiate it. Oh boy. Well, this is nasty. All right, let's try one more example, maybe 2 more if we have time. Have some more partial fraction problems. So what if you end up with 2x squared minus x minus 1 all over x squared plus 1 times x minus 2? Now, in this case, we have a quadratic factor that can't be factored. So when that is the case, you need to set it up like this. You are going to set this equal to ax plus b divided by x squared plus 1 plus c over x minus 2. So basically, you need to have this be linear if your factor is quadratic. Okay, again, probably too much to show the algebra behind it, so you're going to have to just take it as fact. Now you're going to multiply by least common denominator and get 2x squared minus x minus 1 is equal to ax plus b times x minus 2 plus c times x squared plus 1. So 2x squared minus x minus 1 is equal to ax squared minus 2ax plus bx minus 2b plus cx squared plus c. So that means that 2 needs to be equal to a plus c, because those are my quadratic coefficients. Negative 1 needs to be equal to negative 2a plus b, because those are my x coefficients. And negative 1, my constant, needs to be equal to negative 2b plus c. So again, I have a system of 3 equations. Now I'm not going to take the time to solve this. What I am going to say is a equals 1, c equals 1, and b equals 1. 1 plus 1 is 2, negative 2 plus 1 is negative 1, negative 2 plus 1 is negative 1. So this checks out. You could use a matrix to solve that, or substitution or elimination. That's true. So this now becomes the antiderivative of ax plus b, that's x plus 1 divided by x squared plus 1, plus the antiderivative of 1 over x minus 2. So now we have to figure out do we know how to find the antiderivative of x plus 1 over x squared plus 1? X plus 1 over x squared plus 1. Well, we don't, but we know that this can actually be broken apart as x over x squared plus 1 plus 1 over x squared plus 1 plus this one, 1 over x minus 2. So this x over x squared plus 1 is just a natural log of x squared plus 1, because then you could do a u substitution here with u equal to x squared plus 1. So this is going to be 1/2 natural log absolute value x squared plus 1. This is arctan. And this is ln absolute x minus 2. So we got a little crunched there, but this would definitely work, because you'd get 1 over x squared plus 1 times 2x, and then times the 1/2 would give you the x. So that is kind of a tough problem, but the takeaway is, if you have a quadratic factor that you cannot factor, you need to put a linear factor above it. Oh boy. All right, I've got one more problem for you guys, and then we're going to call it quits. So let's take this one. Antiderivative x cubed minus 7x squared plus 10x plus 1, all divided by x squared minus 7x plus 10 dx. Now, in this case, the numerator has a higher degree than the denominator. So if that happens, you need to divide first. So we are going to put x squared minus 7x plus 10 into x cubed minus 7x squared plus 10x plus 1. And yes, we are bringing long division back. X squared goes into x cubed x times. So we get x cubed minus 7x squared plus 10x. And that's nice, because all that's left is 1. So that's good. That basically tells us that this antiderivative is equal to x plus 1 over x squared minus 7x plus 10. So, right, because if I multiply this by this, I will get x cubed minus 7x plus 10x, and then adding the 1, I'll get this. So this is really just, I forget the divisor, quotient, yada, 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 but this is definitely equal to that. I think this is the quotient plus the remainder over the divisor, or the dividend. I don't know, whatever. Anyway, the point is that this is now the antiderivative of x dx plus the antiderivative of 1 over x minus 5 times x minus 2 dx. And this you can apply partial fractions to. And this is happiness. So I'm not going to complete this problem, but you can definitely do it. I encourage you to look on page 355 for a summary of all this stuff. It's a lot. I think page 355 has a nice summary of all this. I'm just going to check really quickly here. Page 355 in your textbook has a nice summary and strategy for integrating a rational function. So you can look at that. And just be thankful we're not doing trigonometric substitution yet. Okay, hope that made sense. Okay, bye.